Okay, in this lesson we're going to continue our study on inverse functions. In this lesson though, we're going to be interested in determining the values of functions and their inverses, and you're going to be given basically tables to evaluate these inverse functions at specified values. So let's look at some examples with this. So if you look at number one, you're given this table for f of x. So there's your table function, and you've had these things before. And you want to find the table for the inverse. So remember, this is f of x. You want to create one for the inverse. Once you do that, then you're going to answer these questions or these items that follow. What you got to remember, though, when creating an inverse function is from information that you had in previous lessons. So remember, inverses undo each other. So remember when we talked about the fact that the x becomes the y becomes the x, and so that's what's going to happen here. So here's your answer. So you can do something like this. So let's go ahead and create the inverse table. So we have, okay, so when creating the inverse table, you're going to have x, and then since this is f of x, you're going to say f inverse of x, okay? All right, now remember, the x becomes the y, and the y becomes the x. All right, so remember, this is y, and this is y, the inverse, okay? So that means that negative 2 becomes y for the inverse, and y becomes x for the inverse. So your coordinates are interchanged. All right, so negative 1, 5 becomes 5, negative 1, okay? 3, negative 2 becomes negative 2, 3, and so on. 7, 8 becomes 8, 7. 4, negative 1 becomes negative 1, 4. So remember, the x, so remember this right here, the x becomes the y of your inverse, and the y becomes the x of your inverse. Okay, so that's important to see that. Now once you get your table, once you get your inverse table, then it's pretty easy to determine the rest. Okay, so let's go ahead and do the domain and range of f of x and f inverse. So the domain of f of x. Now since your function is a finite set of ordered pairs, your domain will be a finite set of coordinates, of elements. So you're going to list in set notation. So you're going to say, remember, the domain of f of x is your x coordinates. So you have x, you have negative 2, negative 1, 3, 7, 4. Okay? Then the range of f of x is, so that's your set of y coordinates for your function f. So that's going to be 3, 5, negative 2, 8, negative 1. The domain of your inverse, so make sure you're saying inverse correctly, make sure you write that notation. So you go to your inverse table. So the domain is a set of x coordinates, so that's 3, 5, negative 2, 8, negative 1. And the range of the inverse is going to be your y coordinates of the inverse. So negative 2, negative 1, 3, 7, 4. Okay? And just like we talked about, the x becomes the y of the inverse, and the y of f of x becomes the x of the inverse, the same thing applies to the domain and range. So notice, the domain of f of x becomes the range of the inverse. The range of f of x becomes the domain of the inverse. Okay? All right, now let's go ahead and find these. Now before we do that, I want to remind you what these tables represent. So this is just a reminder. So if I go back over here to this table, f of x, I want you to understand what this means. So this table right here means this. This means f of negative 2 equals 3. That's what that means. See this right here? That's what that means. This right here, it means f of negative 1 equals 5. So remember, this right here says when x is negative 2, the y value of f of x is 3. When x is negative 1, the y value of f of x is 5. So make sure you understand that. So let's do a couple more. So again, this right here would mean that f of 3, so when x is 3, the y value of my function is negative 2. My function f of x is negative 2. Okay? So when I do this one right here, when I look at that one, I want you to understand what that means. Okay? So that means this. I'm going to go and put it on the side. So the same idea, this means, remember this is f inverse, so that means that f inverse, the first one here, so that means that f inverse of 3 is negative 2. So my inverse function, when x is 3, the inverse of 3 is negative 2. Okay? So again, go here, f inverse of 5 means negative 1. Okay? So that's what that means. So keep that in mind. That's very helpful to know. Okay. Now let's go and answer these. Let's do the first one, f of 3. So letter A, f of 3. So okay, so remember you have two tables, right? You have a table for f of x and you have a table for its inverse. So this is this is your function f here. It has nothing to do with the inverse. So you make sure you use a correct table. So again, this says when x is 3, what is the y value of f of x? So when x is 3, I find it here, the y value is negative 2. So the answer here is negative 2. Okay? Now let's do B. Now this is where you're starting to talk about the inverse. So B says find the inverse of negative 2. So make sure you go to the correct table. So I go to this table. So remember, here's your inverse table. So this is your x value right here. So when x is negative 2, what is the value of the inverse at negative 2? So what's the value of the inverse at negative 2? Well, the answer is 3. Okay? So if we continued on, I just want you to understand this. If we continue on this process right here, the next one would say f inverse of negative 2 is 3. And that's what this is. You see that right here? See that? So if you need to kind of rewrite this table like this so you can understand what you're dealing with. All right? C. Okay, in letter C, you have f inverse of negative 1. So f inverse of negative 1. So again, make sure you go to the correct table. So I'm going to my inverse table. So when x is negative 1, what is the inverse of negative 1? That's what that says. So the inverse of negative 1 is 4. My y value of my inverse function is 4. D. So I want to find f inverse of 3. All right, so again, make sure you go to the correct table. So my inverse table. So when x is 3, so make sure you use the right one. You see there are two 3's here, one for x and then one for the inverse, the y value. So this says when x is 3, so that's this one, what is the inverse of 3? Well, the inverse of 3 is negative 2. Okay? And that's what it is. So it does help. It is very helpful if you think about these tables like you've had in the past. Okay? All right, so that's number 1. Okay, let's look at number 2. Number 2, we have this. Number 2. So this will be number 2. So same idea, right? It's the same idea we just talked about. So you're given the function g of x, a table for g of x, but you want to find the inverse. Now, many students will go ahead and answer these using this table, and you can do that. But some students prefer, since I'm trying to find the inverse, some students prefer to create an inverse table. So create an inverse table for g of x. All right, so this is g of x, here's its inverse. So it does help to do that. It really does. So this is x, and this will be g inverse of x. So remember, you interchange the coordinates. So and notice the arrow. So the x becomes the y of the inverse, and the y becomes the x of the inverse. Okay? So if you need to do those arrows, you do that. It's helpful. So this becomes negative 2, 3. So when x is negative 2, the inverse of negative 2 is 3. When x is 5, the inverse of 5 is 4. When x is negative 1, the inverse of negative 1 is negative 2. So you see I'm interchanging the coordinates. When x is 0, the inverse of 0 is 6. All right? So remember what this means. Remember what this means. This means for the inverse, this means G inverse of negative 2 is 3. That's what this means right here. That's what this ordered pair means. G inverse of negative 2 is 3. And in fact, that's the first one I want to find, right? G inverse of negative 2 is what? 3. Let's do the other one. G inverse of 0. Well, G inverse of 0, that's this one here. So G inverse of 0 is what? 6. All right? And so on. Okay? So that was number 2. So it's not very difficult. Fairly simple thing, right? All right, let's look at number 3. Okay, so number 3. Don't let these compositions throw you off. You've dealt with compositions in previous lessons, so don't let them throw you off. Okay? But you do have inverses involved, so you may want to create your inverse tables. So keep that in mind. All right, so basically you have two tables here. You have a table for f of x, and you have a table of values for g of x. And you want to find each of the following. All right, now notice that you have inverses for g and f being involved here. So let's go ahead. It is very helpful. You notice it is helpful. It is helpful to create your inverse tables. So I'm going to go ahead and, since I don't have enough room here, I'm going to go ahead and do this on another sheet of paper. So real quickly, let's go ahead. I'm going to go ahead and rewrite the function tables, and then we're going to talk about the inverse. Okay, so in number 3, again, you have two tables, one for f of x and one for g of x. So what I'm going to do, what I did was I just rewrote them over, and to answer these questions, see there are some inverses involved, right? So to answer these questions, when you're dealing with the table, it is very helpful to you to create your inverse tables. All right, so let's go ahead and create our inverse tables. And so let's do f inverse of x first. So here's f, here's the inverse. So remember what happens. The x becomes the y. So notice I'm doing the little arrows here. So x becomes the y of the inverse, and the y of x, of f of x becomes your x. Okay, so you see this? If you got to draw these little arrows, you draw those arrows, okay? So you interchange them. So 0, negative 1 becomes negative 1, 0. Negative 2, 4 becomes 4, negative 2. 2, negative 2 becomes negative 2, 2. 4, 7 becomes 7, 4. 8, 0 becomes 0, 8. And then 5, negative 3 becomes negative 3, 5. Okay? Then you do the same thing for the inverse of g. You do the same thing. Once you create those tables, then the rest is very simple. It is very simple. X, G inverse. So again, the domain of f of g of x becomes the range of the inverse. The range of g of x becomes the domain of the inverse. So there's your f of x and g of x function. Those are the inverses. So negative 2, 7 becomes 7, negative 2. 0, negative 2 becomes negative 2, 0. Negative 8, 4 becomes 4, negative 8. 2, 8 becomes 8, 2. 4, negative 3 becomes negative 3, 4. And 9, 0 becomes 0, 9. Okay? So that's the first thing I would have done. All right, now let's go ahead and answer these questions. So here's the first one. F composed with G at 2. So here's letter A. F composed with G at 2. All right, so remember these are compositions. So by definition, this means F of G of 2. So the order in which you see it is the order in which you rewrite it. Okay, now remember what this part right here means. So if you need to cover up that, so always do the inside first. So if you need to cover this part up, you cover that part up. So this says you find G of 2. So you go to your function G, you go to your function G table. That's this one here. So this says when x is 2, what's the y value of my function G of x? So when x is 2, that's this right here, G of 2 is 8. So this becomes 8 right here, okay? Now be careful, that's not your answer to the problem. That is just G of 2, so it's important you see that. So then you got to find now f of, and we always said G of 2 was 8, so f of 8. So now what that means is you go to function f now. So that's this one. So you look up x equal 8, so that's here, so that's where x is 8, and then the question is what's the y value? So the y value is 0, so this becomes 0. So what that means is that this right here is equal to 0. So your answer, you're going to say f composed with g at 2 is equal to 0. Okay? All right, let's look at B. So let me go ahead and do B right here. All right, here's B. So in B, you want to find g composed with f at negative 2. Okay, know your definitions. It's important to know your definition for composition. By definition, this means g of f of negative 2. Okay, the order in which you see it is the order in which you rewrite it. Cover this part up. And so remember, you're finding the inside function, the inside part first. So you got to find f of negative 2. So make sure you go, see there are 4 tables here. Make sure you go to correct one. So I got to go to my function f. So that's this. See, f of x, g of x, f inverse, g inverse. So f of x. So this says when x is negative 2, so that's this right here, see it? What is the y value? So f of negative 2 is 4. So this is 4, not the answer to the problem. Okay? This is 4. So now you got to find g of 4. So now I'll go to my function g, which is this, and so g of 4 is negative 3. So that becomes negative 3. So therefore your answer, you're going to say g composed with f at negative 2 equals negative 3. Okay, that's negative 3 right here. All right, so that's B. So not difficult, right? It's fairly simple to deal with. As long as you rewrite your tables, of course you didn't need your inverses yet, but that's how you do A and B. All right, now we're going to be dealing with inverses. So let's look at C. So C, you have f composed with g inverse at 8. Well, by definition, this means f of g inverse of 8. That's what that means, okay? So f of g inverse of 8. See, this part here is this, okay? All right, now we got to find g inverse of 8. So make sure you go to the correct table. So I got to go to my g inverse table. That's this one, you see it? So when x is 8, so we see x, here's your x row. So when x is 8, g inverse of 8 is 2, okay? 2. So this is 2 here. So now I got to find f of 2. So make sure you go to the correct table. So now this is f. So that's this. So f of 2 says what when x is 2, what's f of 2? What's the y value? Well, when x is 2, see x is 2 here, the y value is negative 2. So it becomes negative 2. So your answer, you're going to say f composed with g inverse at 8 equals negative 2. All right, let's look at D. All right, D, you have this for D. All right, D, you have G composed with F inverse at 4. All right, by definition, this means G of F inverse of 4. So I got to find this part first. So I got to go to my F inverse function. So that's this one, right? And so when x is 4, so x is 4 here, then that says F inverse of 4 is negative 2. So this is negative 2. So now we've got to find g of negative 2. So this says you go to your function g, so make sure you go into the correct table. So that's this one. Okay, don't get all these tables confused. It's easy to see what they are. F of x, g of x, F inverse, g inverse. So g of negative 2, so when x is negative 2, it's right here. G of negative 2 is 7. So your answer, you're going to say G composed with F inverse at 4 equals 7. Okay? All right, let's do E. So in E, you want to find F inverse composed with G at 0. Okay, F inverse composed with G at 0. So by definition, this means F inverse of G of 0. So you see this right here is this. Okay? So now we got to find G of 0. So let's go to our tables. Now make sure you write so I'm covering this up. You got to go to your table G of x. So that's this one, right? So let's find G of 0. So when x is 0, which is here, G of 0 is negative 2. So now I've got to find F inverse of negative 2. See, the G of 0 is negative 2. So then I go to my F inverse function. You go to your F inverse function. So that's this one. And so you're trying to find f inverse of negative 2. So here's x equal negative 2. So f inverse of negative 2 is 2. So that's equal to 2. So your answer, you're going to say f inverse composed with g at 0 equals 2. Okay? All right, let's look at f. All right, I'm trying to see if I can put this, maybe I can do this. So I'm going to do this on the side. So this will be f. So f, I have g inverse composed with f at 4. Well, by definition, this means g inverse of f of 4. So now we got to find f of 4. So if you need to cover up this part here, remember you got to do the inside first. You got to find f of 4. So I got to go to my function f. So that's this right here. Y'all see it? Let me go ahead and put it on this side. Okay, so that's so f of 4. So that's your function f of x here. So f of 4. So when x is 4, so that's this. What's the y value? So f of 4 is 7. So this part's 7. So now I got to find g inverse of 7, right? Okay, so then you got to make sure you go to your g inverse function. So that's this table right here. Okay, so I'm going to move it over again. All right, so g inverse of 7. So when x is 7, so that's this right here, g inverse of 7 is negative 2. So that becomes negative 2. So your answer, you're going to say g inverse. So g inverse composed with f at 4 equals negative 2. All right? And then g, the last one in this problem. So g, you want to find g inverse composed with f at 5. Well, by definition, this means g inverse of f of 5. So then remember, cover up. If you need to cover up this part here, because this is what you got to do first, and you do that first. So this says I go to my function f. So that's this table here. So watch, I'm going to move this over a little. All right, so that's this table here. You'll see it? Okay, right here. So when x is 5, that's right here. See it? F of 5 is negative 3. So that's negative 3. So now you got to find g inverse of negative 3, right? And so g inverse of negative 3, I go here now. So g inverse of negative 3, let me see if I can move it over. You see right here? Right here. So when x is negative 3, my y value of the inverse, so when x is negative 3, my y value of the inverse is 4. So that's 4. And so therefore, you're going to say, as your answer, you're going to say g inverse composed with f at 5 equals 4. Okay? All right, so that was number 3, and that's all that is. All right, it's not difficult, just knowing how to create inverse tables for your functions, and then remembering compositions. That's all that is. All right, so let's look at number 4. So this is number 4. So in number 4, we have this, okay? And it says this: use the table to determine if. Now you have two functions, they're both called f of x. So use the table to determine if f of x is a one-to-one function. Okay? And if it is, then you find the table for the inverse. Okay, so remember the definition of one-to-one function. So the definition, but let me go ahead and write this right here. So the definition of one-to-one function, is, first of all, it must be a function. So it's a function. So a function. So it has to be a function, right? So a function in which for each y coordinate there is exactly one x coordinate associated with it. Okay, associated with it. All right, so that was the definition of a one-to-one function that we talked about in a previous lesson. So a function in which for each y coordinate there's exactly one x coordinate associated with it. So first of all, it's got to be a function. So first of all, we need to determine if this is a function. Okay, and if it's a one-to-one function. Well, actually, they're both functions because notice the function notation. So for each x coordinate, there's one y, and you see that here: -2, 5, 0, 7, and so on. So those are functions. Then we got to determine if it's one-to-one. If it's one-to-one, then it has an inverse. All right. So let's talk about let's see if it's one-to-one. So this is part A. So the question you gotta ask yourself is this: is it a one-to-one function? Okay. You got to answer that question first. So remember what that means. That means that for each y, there's exactly one x. So remember that mapping we did when we talked about functions? Remember with functions in a previous lesson a while back? For each x, there's got to be one y. For a one-to-one function, for each y, there's got to be one x. So let's check it. So remember, f of x is your y. So 5 gets mapped to -2. So we're good so far. 7 gets mapped to 0. We're good so far. -2 gets mapped to 8. And then 6 gets mapped to 4. So notice that for each y coordinate, there's exactly one x, right? So this is a one-to-one function. So this is a one-to-one function. So yes, it is one-to-one. So now we can create the inverse function, the table for the inverse function. So here's how you do that. So remember, you just interchange the coordinates. So the domain becomes the range of the inverse, remember that? And the range becomes the domain. So -2, 5 becomes 5, -2. 0, 7 becomes 7, 0. 8, -2 becomes -2, 8. And then 4, 6 becomes 6, 4. You're done. So you answered, yes, it's a one-to-one function. You saw that. And you just interchange the coordinates. Okay, but make sure you say f inverse of x. Let's look at B. So in B, we got to determine if this function is a one-to-one function. So let's see if it is. So I'm going to say y and x. So when y is 7, it gets mapped to 4. When y is 2, it gets mapped to -3. So far we're good. For each x, there's only one y. When y is 9, it gets mapped to 5. So far we're good. When x is 7, I already have a 7, so don't draw it again because then you're gonna mess up. Because what most students do is they say, hey, I only see one arrow coming from each number. Well, if you put the 7 again, you do see one arrow, but the problem is that you already had a 7. So use this 7. So when y is 7, I get a y value of 8. This is not one-to-one, because remember the definition of one-to-one says that for each y coordinate there's exactly one x. Notice that when y is 7, how many x values do you see? There are 2. So this is not a one-to-one function, so there's no inverse. So there's no inverse for f of x. Okay? So there's no inverse for f of x. All right? Okay. So that was number 4. Okay, let's look at number 5. So in number 5, we have this. Number 5, we have this. So we have, so it says this: assume that the function f is one-to-one with this domain. And the reason they said domain's all real numbers, see, negative infinity means all real numbers, is because you don't have to worry about see here in your function, this is x and this is y. Okay, when you do the inverse, you don't know anything about the domain of the inverse. All right, so just assume that it's a one-to-one function, and f has this domain. So remember, if this is the domain of f, then the range of f inverse will be this as well. Okay, so let's think about what this is. Let's go back to a previous problem we saw earlier. I just want to remind you about something. So remember, let's see if I can get to it. Okay, so remember number 1, when we went and we kind of discussed what these tables imply in terms of our notations. So I want you to see this. You see where we had f of -2 is 3, and then in that other table, the inverse table, we saw this f inverse of 3 was -2, right? So basically what this is saying is this. So if f of -2 is 3, then without even knowing the inverse table, without even creating the inverse table, you can say this. Well, if f of negative 2 is 3, meaning this, f of negative 2 is 3, then what that means is that f inverse, see this becomes the y of the inverse. So the f inverse of 3 is equal to 2. That's what that means. Okay? All right, so let's discuss this again. So remember what this says. So in terms of a table, this would imply that when x is negative 2, f of x is 3. If you were to create the inverse table, what that would imply, so here's x, here's the inverse. So remember, x, the x becomes the y, right? And the y becomes the x. So when you found this one, you're saying f inverse of 3, right here, this 3 and this 3. So we're talking about inverse, so let's talk about this 3. So this 3, so f inverse of 3 is negative, oops, that's supposed to be negative 2? Yeah, negative 2, I'm sorry, negative 2, just negative 2. Okay, so f inverse of 3 is negative 2. So if you had, let me just kind of do another one. So if you had, let's say this one here. So if we had f of negative 1 is 5, okay, what that means is that when x is 5, f of x is negative 1, right? So if I want to determine the inverse of, so when you do the inverse, you're now taking the inverse of this. So the inverse of 5, so remember, this is your y, so the y becomes the x of the inverse. Okay, so the 3 becomes the x of the inverse. So the 5 becomes the x of the inverse, and the x coordinate of your function becomes the y coordinate of your inverse. So when I go here, right here, so f of 3 equals 7. If I look at it in terms of a table, just look at this, just follow me along. If x is 3, y is 7, right? And so if I talk about the inverse, if I do the inverse, then what that means is that so when x is 7, y of the inverse is 3. So you see what it says is f inverse of 7. So f inverse of 7 then would be f inverse of 7 then would be 3. So the x coordinate of your function f of x becomes the y coordinate of the inverse. The y coordinate of your f of x becomes the x coordinate of the inverse. All right. So this answer here is f inverse of 7 is 3. So if you need to kind of do a table, then do a table. So for example, let's look at B. So in B, you have g of 4 is equal to negative 3. So in terms of a table in your mind, what that means is this. When x is 4, g of x will be negative 3. So in terms of the inverse, what that means then is that, okay, so remember your interchange, right? So that means that when x is negative 3, your y value will be 4 for the inverse. So that means this. So if g of 4 equal negative 3, you don't even have to think about this anymore. You know this. G inverse of negative 3 is going to be 4. So g inverse of negative 3 is going to be 4. All right? So make sure you understand this. So watch. Let's do another one again. So make sure you see this. So if g of 7 is 2, let's say, okay? So what that means is this. That means that when x is when x is 7, the y value, so g of 7 is 2, right? If I talk about the inverse, so remember when you do the inverse, you interchange the coordinates. So 7, 2 becomes 2, 7. So the x becomes the y of the inverse, and the y becomes the x of the inverse. So what that means then is that if g of 7 is 2, then we know that g inverse of 2 is 7. And it's true because look, So G inverse of 2, so here's G inverse of 2 is what? 7. Okay, so real quick without thinking about the table, if f of 8 is negative 3, then what can you say? If f of 8 is negative 3, then f inverse of what? What's going to go here, you think? Negative 3 will equal 8. Okay? And check it. So check it. Here's x, here's f of x. So when x is 8, my y value is negative 3. Okay? For the inverse, you interchange the coordinates. So through negative 3, 8. So f inverse of negative 3 is 8. That's what that says. F inverse of negative 3 is 8. Okay? That's all that is. Very, very simple idea. And then let's look at and this is going to be number 6. So number 6. Okay. Assume that the function f is 1 to 1. And then you want to find this. F inverse composed with f at 8 and G inverse composed with G at negative 5. All right. So here's what you got to think about. Do you remember there was a lesson that said that inverses undo each other? Okay. So inverses undo each other, right? So there was a lesson that talked about that, and we saw that. So notice that and let me cover this part up. So notice that that these two functions are inverse of each other. So the f and f inverse are inverses. So if you think about what this is right here, so let's think about this. Watch. This becomes f inverse composed with f at 8. Okay. So this says this part right here says this. I'm going to take x, listen to my words. I'm taking x and putting it into my function. Okay? Whatever that y value is, I'm going to put it into the inverse. But remember, the inverse undoes what your function did. So if your function took 8 and did some stuff to it, okay, and got a y value, then the inverse will take that y value, undo all of it, and give you what you started out with. And so what did I start out with? I started out with 8. So whenever you're talking about f and f inverse in terms of composition, then it's just going to be what you started out with, because they undo each other. So they undo each other. So let's talk about this one. Same idea here. So this is G inverse of G of negative 5. So let's talk about what that means. So first of all, this part means this. I'm taking x equal negative 5. Okay, x equal negative 5. And I'm putting it into G. Whatever G is, I don't know what G is, but whatever G is doing something to negative 5. And I'm going to get a y value. Then I'm going to take this y value, and I'm going to put it into the inverse of G. So remember, they undo each other. So G inverse undoes what this did. So if I take x, which is negative 5, put it into the function g of x, I'm going to get a y value. I'm going to take that y value and put it into the inverse. Well, that inverse is going to undo all of those operations that occurred and give me back what I started out with. And what I started out with is x, which is negative 5. Okay? All right, so that to be honest with you, is a little bit confusing for students, for some students. But just think about that. Just think about what it's saying. So by definition, first of all, by definition, it's this. And you don't know what f is. You're not given the equation for f of x. You're not given the equation for g of x. So you don't know what that is. But it's not necessary here, because f and f inverse are in f and f inverse are inverse of each other, so they undo each other. So if you take x equal 8, put into your function f, it's doing some operations to this. Okay, you're going to get a y value. You're going to take that y value, put it into the inverse. The inverse is going to do all of it. It's going to do all of what f did, and is going to get you back to what you started out with, which is 8. Okay. All right, guys, so that is this part of, and let me go ahead and find the original page. So that is going to be this part of our study on inverse functions. And so remember what we did, so we hopefully through all these problems you're able to determine values of functions that are inverses, and you are able to use tables and create tables for inverses to find to evaluate inverse functions at specific values.